so this is going to be the data interpretation chapter. So if you're watching this on YouTube later, just remember, just kind of stay for the beginning brief notes section before attempting the problems on your own and doing corrections on your own before coming back to watching the explanations for anything you're stuck on. So really quick, let me put this as a bookmarker. We're going to go over some of the formulas that you might need for interpreting data on the exam. So in chapter 4, there's a bunch of the math formula stuff. There's 5 pages of it. 4, and I'm on the wrong page. There we go. And in the first page of the math formula stuff, there's a bunch of stuff for mean, median, mode, standard deviation, all that kind of stuff. So mean, which we also call average, is just the sum of the data points that you have divided by how many data points are in the list. The median is just the middle number in your list of data points. The mode is going to be the one that shows up the most frequently in your list. So let's say that you had, it's a new book, so it's all not pressed. Okay, there we go. So let's say you had the numbers like this in your list, where it's 1, 2, 2, 3. The number that occurs the most frequently is 2, so your mode would be 2. If I wanted to find the mean of this list, it would be 1 plus 2 plus 2 plus 3, which 1 plus 2 plus 2 plus 3 is just going to be 8. Oh my goodness, that is so annoying. Okay. So then that's going to be 8 when I add all those up, divided by how many numbers are in my list, which would be 4. So then the mean here would be equal to 2. Now the median in this list, you'll notice it's an even number list. When that happens, we have 2 middle numbers. So when that happens, you have to take the average of those two. So 2 plus 2 divided by 2 is going to be 4 over 2, which is just 2. So 2 is the median. Now, if our list happened to be 1, 2, 3, the median middle number would be 2 here. So if you have 2 numbers in the middle, you take the average of them. If you have just 1, it's just that 1 number in the middle. But remember, if they gave you the list like this, let's say that they gave it to you like this, the median is not 1. You first need to put it in order. You need to say 1, 2, 3, order from least to greatest, or you could do greatest to least. I just always do least to greatest. You have to put it in order before you determine what's in the middle, or else you'll get it wrong. Now the range, let's say that we had the list was 1, 2, 3. The range is going to be the biggest minus the smallest number. So it's going to be 3 minus 1 is equal to 2. That's the range. Now, standard deviation is, it's in the name. That's a great thing about math. A lot of the names go with what they mean. So standard deviation is how far the list strays or deviates from the standard, which we could also call mean. So how far your list goes away from the mean, the numbers in your list go from the mean. So if you are decreasing your standard deviation, that means that you have more numbers closer to the mean. If you're increasing your standard deviation, that means there's more numbers in your list that are further away from the average or the mean. So this would happen with outliers. If you add more outliers to your list, numbers that are super big or super small compared to the numbers in your list, you're adding more numbers that are farther from your average in your list. So then you're going to be increasing your standard deviation. So those are just a couple reminders really quick before we start this chapter. So let's go and do this one. So it says we're using this information for numbers 1 through 4. So Elizabeth decides to ride her bike to visit a hiking trail. She starts her commute by leaving her home and traveling in the direction of the hiking trail. Her distance from home is represented as a function of time in the graph below, where y is equal to dt, and d is the distance from home in miles, and t is the number of minutes since she left home. So it says for number 1, someone just asked where they can get this book. It's available on Amazon, Overcoming ACT by Sophia Garcia. This is not for the digital SAT. This is for the ACT. I do have one for the paper SAT right now. I'm not updating it to be with the digital one until winter break. But I will be updating the book for the SAT version to go with the digital. I want to wait till they stop giving the paper exams before I do that. So then let's go to this next one. So it says, during what period of time was Elizabeth traveling the fastest? Okay, so let's see. If we want to know how fast she's going, remember, this is the distance that she's traveling from home, and this is going to be the time. So remember, distance like you could think of a d equals RT, where R is the rate, and then you could just say, hey, I'm going to divide by T on each side, and that equals the rate or the speed. Or you could just memorize this formula, whatever you prefer. But basically the rate or the speed is going to be the distance divided by the time. So if we think about what's the distance divided by the time here, we're talking about slope, essentially. So we have to ask ourselves, okay, what's our slope, and when is it going to be, when's our slope going to be the greatest, because that's when it's going to be the fastest. So, or the absolute value of our slope is kind of how you could think about it too, because, well, actually, we're not doing like velocity, we're doing speed. Hold on, I'm confusing myself. Let's just do this, because I'm going to mess up the words, I know it. You'll see it with when I do the numbers. So the slope right here, from here to here, it's just going up by like 1 and 1. Technically, it's not by 1 each time, like this is, what is it, going up by? So it's going up by 5, 10, 15, 20. It's going up by 5 each time. So if you want to be exact, like you could say 5 over 5, but that's the same thing as like it's going up 1 by 1 if like you're just using the squares to kind of think of the slope. But technically it's like 5 over 5, which is equal to 1. So like the slope is 1 right there. The slope over here, this is just 0 slope. So that's 0. This one's also 5 over 5, up 5 over 5. So that's equal to 1. This one's going to be negative 1. This one is going to be up 10 over 10. So that's going to be, again, 1. And then this one is just going, look, every single box, down 1 over 1, down 1 over 1. So it's minus 1. Now remember, it's saying speed. So if you're thinking about velocity, that's the one with the direction. That's what I was trying to say at the beginning where I was like stumbling up on my words. We're not worried about velocity, so we're not worried about like it being negative or positive. We're worried about speed. So like the speed would be just like the absolute value of these. So just like positive 1 is how we would think of these instead of negative 1. So all of these are equal to each other except for like the 0 portion right here. So if we're talking about like where she's traveling the fastest when she is traveling, it's the same the entire time. So it would be E. Now here, that's like where she's taking a little break or something because like she's not moving, like her distance is not changing. So then let's go to number 2, which says sometime after her snack break, Elizabeth realizes that her bracelet has fallen off and turns around to search for it before continuing her commute to the hiking trail. For which of the following time intervals did Elizabeth turn around and search for her bracelet? So remember, this D is her distance from home, so it would be like increasing as she's going away from her home. If she's stopped, then it's like not going to be changing, and if she's going like towards her home, then that means the distance away from her home should be getting lesser. So we're basically asking ourselves, like, when is the distance that she is from home decreasing, basically? Like, when is D going to be decreasing? So let's see. Well, this is increasing. This is like remaining at like no change. Like it's just 0 right there. Then this is increasing the distance from home. This is going to be decreasing from home. And then this is also going to be decreasing, but this would be like, in the context of this is probably her like going back home, you know, because like she's going to her, what was it, like a biking or a hiking trail. And then this is probably her going back home. So it's going to be this one right here. So then this would be 15 to 20 minutes. So then that would be H. So number 3 says, on which of the following intervals is Elizabeth's distance from home strictly decreasing then increasing? So we want it to be decreasing, which means it goes like this, and then increasing, going like that. So from that to that. So where is it doing that? Well, that's going to be like right here, decreasing then increasing. So then that would be from 15 to 30. So it would be C. So then let's go to number 4. Which of the following is closest to Elizabeth's average speed in miles per hour for the parts where she was riding her bike? So average speed in miles per hour. Let's see. So where is this? Hold on. So this is minutes. T is in minutes, right? Yes, T is in minutes. So we have to be careful about that. They're asking for miles per hour. And they said D is already in miles. So we don't have to convert anything for D, but we do need to convert the T to minutes. So let's see. That would be 60 minutes is just like 1 hour. So, I mean, you don't really have to do much converting right here. If you want to do like the whole stoichiometry thing, like 60 minutes, there's 60 minutes in an hour. You could technically do this, but I feel like a lot of people just know that there's like, there's 60 minutes in an hour, so you could just say it's an hour, but that's how you do it with stoichiometry if you want to see that. So then we want to do the average speed in miles per hour. So like, that would be, let's see, well, we already figured out what the slope was. It's just 1 over 1. So then it would just be 1 is the slope. So 1 over 1. So then we would have to say, hold on, 1 mile for every 1 minute was what it was in. And then we would say, okay, there's 60 minutes an hour. So it's just 60 miles per hour. So it would be K. So then let's go to number 5, which says the graph above summarizes the expenses of 3 different companies, Company A, Company B, and Company C in 2015. According to the graph, which company had the lowest combined office and travel expenses in 2015? So we want, this is like the black bar is office, the blue, or not blue, the gray bar is travel. She's spiking 60 miles per hour, yeah. So then we want lowest combined expenses. So let's see, this is in millions, so just remember that, like if we need it later. But this would be 12 million, and then this is 9 million. So this would be 12 plus 9 is going to be 21, so 21 million is the combined expenses for A. Now let's do the combined expenses for B. Well, that would be 7 plus 7, which is just going to be 14 mil. And then over here, that's going to be 10, and then this is going to be 3. So this is going to be 13 mil. So who had the lowest combined office and travel expenses? That would be Company C. So let's go to now number 6, which says if the total amount of expenses for all 3 companies is 48 million, then which of the following is closest to the percent of expenses made by Company C? So let's see, Company C, and it's just saying regular, so just expenses. Okay, so we don't have to worry about it being office or travel. It's just general expenses. So it would be 13 million is what Company C did. Out of, let's see, that's going to be 48 million. Whoops. And then we're going to say that we're going to multiply the fraction by 100 to get it as a percent to see which of these is it closest to. Hold on, where did I put my calculator? I'll just use my computer calculator. Hold on one second, guys. Let me just put that in. 13 divided by, it's 48, and then times 100. So then that's going to be 27.08333333, yada, yada, yada. So that's going to be H. So let's go now to number 7. So for number 7, it says, which of the following conclusions can be drawn? So let's see, more overall office expenses can be attributed to office expenses than travel expenses. Okay, so like, let's see, let's compare. It basically looks like A and B are comparing office and travel expenses for everybody. So let's see, this would be 12. So like, remember, the black is the office. So this would be 12. This is 9. This is 7 and 7. This is going to be, what does it say? 10 and 3. So the total office expenses would be the black bars all added up. So 12 plus 7 is 19, plus 10 is 29. So this is going to be 29 mil. The travel is going to be the gray bars added up. So that's going to be, ooh, this is supposed to say 3. 3 plus 7 is 10, plus 9 is 19 mil. So the office expenses are more than the travel. So let's see. More of the overall office expenses can be attributed to office expenses than travel expenses. I think that's supposed to say total. I just caught a typo in my book. Total expenses is what that's supposed to say, I think. Yeah, that's what I was going for. Whoopsies. So it would be A. That's supposed to say, like, total, not just office expenses. But, like, you can kind of get that from the context of the problem. I just made a typo. So it's saying, like, more of the, like, the total overall expenses are the office expenses versus the travel expenses, basically. So let's go to number 8. The table below displays a school's record of absences for 672 students by grade level and reason over a month. What fraction of juniors were absent because they were on vacation? So we're looking for juniors on vacation that were absent. So that's going to be, the part we're talking about is 110 out of they're asking the total amount of juniors, like what fraction of the juniors. So this is 110 out of the total juniors, which would be 24 plus 110 plus 33. So let's see, when we add all of that up, that's going to be 110 over 167. So then that's going to be F. So let's now go to the next page. So for number 9, it says, phone store sells family phone plans. They sell 3 different phone plans, A, B, and C. They order various phone models, D, E, and F, that come in the phone plans from a particular manufacturer. Each phone plan contains a different number of each of these phone models. The table below summarizes the cost of each phone model that the store pays the manufacturer and the number of each model included in each phone plan. So like phone plan A has like 2 of the D phones, 1 of the E phones, and 3 of the F phones. And like this is how much each of those phone types costs. For anyone that wants to slow down my voice, just know like these get posted on YouTube later, and YouTube lets you put like in the little settings thing, like on the video for the settings button, click that and it'll allow you to do like half speed or 0.25 speed or whatever to slow it down. So let's go to this one. Says if the phone store plans to sell 2 A's, 3 B's, and 7 C's, then how much will it cost the store to order the necessary phone models from the manufacturer? Okay, so they plan to sell 2 of the A plans. So let's figure out how much the A plans would cost. So each of the A plans has 2 D phones. So that would be 2 times 120 is the cost of the D phones for that plan. 1 E phone, so 1 times 225. 3 of the F phones, so 3 times 300. So we would just have to multiply that all out and add it up to find out how much one of the A phone plans cost. So that would be 1,365 for one of the A's. Now, for one of the B's, it would be, we do the same exact thing. We multiply by like what each of the prices is and then add it all up. Oopsies. So then for one of the B phone plans, that's going to cost $990. Now let's do the same thing, but for the C phone plan. So for the C phone plan, that's going to cost, oh wait, hold on, this one's the $990 one. Whoopsies. $990, and this one's the $720 So that's $720 and that's $990. So then let's see, we have to multiply this by 2, this whole entire thing. So it's this much, 1,365 for phone plan A, but we're going to buy 2 of those according to the problem. So we have to multiply that by 2. So when we multiply that by 2, we're going to get 2,730. And then we're going to say we want 3 B's. So this is the cost of one of the B's is $720. So we're going to say 720 times 3. So then 720 times 3 is going to be 2,160. And then we're going to say we're going to do 7 times C because we're buying 7 of the C plans. So we're going to do 990 times 7, and that's going to be 6,000, what's that say? 6,930. So then we're going to add all of these numbers up. So when we add all of these numbers up, what we should get is 11,820, which would be E. So let's go to number 10. It says, the table below displays a school's record of absences by grade level and reason over a month. If the data is used to estimate absence information about 3,000 total absences in the school year, which of the following is the best estimate of the number of sickness-related absences by sophomores in the school year? Okay, so let's see. We want to know by sickness-related for sophomores. So sickness, sophomores, we're talking about 80. So we're talking about 80 out of the total absences. So the total absences would be represented by, like, this is the total column, so, or total row, I mean. So it'd be 150 plus 105 plus 50, which that's going to be 305. So this is the sophomores that were sick out of the total number of students. that were absent, or student absences. And then they're saying like, hey, this is the chances, and now I want to predict how many sophomores will be sick out of 3,000 total absences. So what you need to do is multiply the fraction of sophomores that would be sick by the total number to find the expected number of absences. So when we do that, we're going to get 786.8, yada, yada, yada. So then that's going to be closest to H. Thank you for the rows. So let's go to number 11. So number 11 says, how many students read 1 to 2 hours per week? Okay, and it says, Anna surveyed students at a nearby high school about their book reading habits. Okay, so we have the results here. So this column is the number of students that are reading for each of these categories of hours per week. So how many students read 1 to 2 hours per week? Well, let's find 1 to 2 hours per week. How many students? That would be 37, so it would be D. Now for number 12, how many students did Anna survey? So remember, these are the number of students for each of the categories in her survey. So all we would have to do to figure out the total number of students that she surveyed would be to add up all these numbers right here. So you would just take your calculator and add up all of these numbers to find out how many students that she surveyed. So that would just be 123. So it would be J. So then let's go to number 13. So it says, suppose the student is selected at random. Which of the following is closest to the probability that the student reads 6 to 11 hours per week? So let's go to 6 to 11 hours per week. That means we're talking about 18 students. So remember, probability is like the part that we're desiring or being asked about, which would be like the 6 to 10 hours per week students, over the total that we're looking at. So the total number of students, remember, we just calculated when we added all this up was 123. So now I just need to put 18 over 123 into my calculator, and that's going to be 0.146 yada, yada, yada. So 0.146 yada, 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 that's closest to, it rounds up to 0.15, so C. 14 says, what is the maximum number of hours that, maximum number of students, that could read 4 hours per week? So maximum number of students that could read 4 hours per week, I'm like, it seems so easy. I'm trying to think if I wrote this as a trick question. Was the maximum number that could read 4 hours per week? I mean, that's 20. They said 20. Oh, yeah, I mean, I guess it's kind of like a trick question, not really. Because like you could think of like the most amount of like students that could read 4 hours is like nobody read 3 hours, nobody read 5 hours. The most that could read was 20, like I guess kind of. So that would be H. So then let's go to, whoops, let me just fix that. So let's go to number 15. If a student is selected at random, then which of the following is closest to the probability that the student reads more than 5 hours per week? So more than 5 hours per week would be these guys right here, because you could do the 6 to 11 hours or 11 or more to still be over 5 hours per week. So we would have to be talking about 18 plus 6 for the number of students out of the total number of students, which we already know is 123. So then that would just be 24 over 123. So just put that in your calculator. And when you do that, you would get like 0.195, yada, yada, yada. So we would see like which of these is that closest to, and that would be closest to A. So then let's go to this one right here. So we're using these tables for 16 through 18. A researcher surveyed 25,000 students at a particular state university. The results of the survey are shown below. Okay, so here's the results. Lunch cost $16 for students 23 and older, and it cost $12.50 for students under the age of 23. What was the average number of students in each of the 4 lunch buying frequencies? Okay, so, lunch buying frequencies right here. So like often, sometimes, all of that. So if we want the average number of these students, remember average is the same thing as mean. So we're just going to add up all of these and divide by how many categories there are, or how many like data points we're adding up, which is technically like the categories is an easier way to think about it. So it would be dividing by 4. So I'm going to add up all these numbers. So I'm going to do 11,020 plus 9,140 plus 3,220 plus 1,620, and I'm going to divide it by the 4 categories for lunch buying frequency. So you would just put that in your calculator, and when you do, you're going to get 6,250. So that would be H. So now let's go to number 17. Number 17 says, suppose that all the students who answered the survey decided to buy lunch this week. If the total amount of revenue that the school cafeteria makes this week is $346,590, then how many students that were under the age of 23 bought lunch this week? Okay, so let's call the students that are 23 and older, like 23 plus X, and let's call the students that are like 23 and under, which I'll say like 23 minus, like 23 and under 23, sorry, would be represented by 23 minus. So like Y is the under 23. So there's going to be, let's see. Then how many students were under the age of 23? So we're basically trying to find out what Y is equal to. And it says right over here, oh, so here's the cost. Okay, that's what I was looking for. So it's $16 for students 23 and older, and $12.50 for students that are, under the age of 23. So if we want to find out, like, the total, if we want to write an equation for the total amount of revenue that they're bringing in, like this number right here, we would say that it would be the cost of each of the lunches for the 23 and over crowd, which would be $16 times how many students X are part of that crowd, plus, what was it, $12.50? Yeah, $12.50 is the cost of under 23 times Y number of students that are under 23, and that has to add up to the total revenue that they made that week. And thank you for the rows, guys. So now what we're going to do, okay, we have one equation, so this is probably a system of equations. So now we could say, okay, we have one, let's find another equation that we can use. Let's see, we could figure out total number of students, so we could just like add these up right here. And then we could say like that's the total number of students. So then that would just be, that's just 25,000, yeah. So that would just be 25,000. So we could say like X plus Y is equal to 25,000. And then now we have a system of equations that we can use to solve for what Y, what Y is. So let's say that X is equal to 25,000 minus Y, and then we could substitute that in for the X value in this equation right here. So I'm going to go to like the scrap paper over here to like do it so I have more room. So that's going to be 16 times, oops, let me fix that. 16 times 25,000 minus Y, and then plus 12.50Y is equal to 346,590. So now what I'm going to do is I'm going to just do like distributive property, combining my like terms and solving for Y. So if I do 16 times 25,000, that's going to be 400,000 minus, and then I have to attribute the 16 to the minus Y, so minus 16Y, plus 12.5, I'm just going to drop the 0 because it doesn't really matter, you can keep it if you want, is equal to 346,590. So now I'm going to combine my like terms here with the Y's. So I'm going to say, okay, I'm going to copy down the 400,000, and I'm going to say, what's minus 16Y plus 12.5Y? And then that's going to be, that's just 3.5. So it's going to be minus 3.5Y, and that equals 346,590. So then I'm going to subtract 400,000 from each side, because remember, I'm trying to get Y by itself. So if I subtract 400,000 from each side, that's going to be 53,410. So now I'm going to divide by negative 3.5 on each side to get Y by itself. So what I'm putting in my calculator now is going to be this right here to find out what Y is. So, oh wait, hold on. Did I Oh, I forgot to put the minus. Minus, this is supposed to be negative, minus 53,000. I was like, why am I getting a negative number? Whoopsies. So then we're going to put this into our calculator, and the negatives would cancel out to a positive, and we're going to get that that's 15,260. So that's the number of under 23 students from the systems of equations that we just solved. So that would be D. So let's go to number 18. So number 18 says one of those 18 or students 18 or older, of those students 18 or older, what fraction are 27 or younger? So of those students that are 18 and older, so basically like out of all of these students, what fraction are 27 or younger? So like this is who they're asking about right here. So who they're asking about, we'll put on top for our fraction out of the total number of students 18 or older, which would just be, all of this added up would be 25,000. So when we add up that top number, we're going to get 24,725 over 25,000. And 25 goes into both of those, so we're going to divide by 25 on top and bottom. And so now just put that in your calculator, and that's 989 on top. And then on the bottom, it would just be 1,000. So that would be K, right over there. Okay, so then let's go to number 19. The table below shows the number of various types of books read by students at Fake High School during the summer. If the number of students who read nonfiction is P% of the total number of students who read books, then which of the following is closest to the value of P? So we want to find the value of P. Okay, so if the number of students who read nonfiction, so 700, is P% of the total number of students who read books, then which of the following? So we have to find out like what this percent of nonfiction is. So 700 is the people reading nonfiction out of the total number of students, which total... Oh, wait, hold on. Yeah. I didn't see that it was total. I was thinking it's another category. Whoopsies. Oh my gosh. I didn't know how to do that. I was thinking I had to like add up all the categories. I didn't even read that total. I was thinking that's like a science fiction or whatever, like one of the genres. That's what I'm doing. It's like, I am not getting any of these numbers. Oh my goodness. Sorry. Okay. So then that's going to be the total. So then we're going to do that times 100. So there's 700 reading nonfiction out of the total, which is going to be 3,200 students times 100 to get the percent. Because to turn a fraction to percent, you just multiply by 100. So then now I'll put that in my calculator. So it's 700 divided by 3,200 equals times 100. 21.875. So 21.875 is going to be your percent, and it's asking which of these is it closest to, so it would be closest to B.